This is section 3.2, and we're solving by substitution. Now, before we solved by graphing, so we graphed both these lines and we solved them. And as you guys could see, there were some times when we graphed them that they weren't exactly perfectly accurate, depending on how our line was drawn and all those things. So sometimes graphing is a really hard way to solve by substitution because it's not necessarily the most accurate way. By substitution, we can solve it much more accurately. Okay, so here's what we're going to do as we look at this. I've put these steps here for you, but some of these steps you're going to do sometimes, some of these you aren't. Okay, so in this first step it says here, solve one of the equations for a single variable. Now, in today's examples, you'll have a variable that will be by itself already in one of the equations. So that'll be the nice part for you. You won't have to do the first step. Then, what you're going to do is you're going to substitute the expression for the variable that you solve for, or the variable that's by itself, okay, into the other equation. So I might say y equals 2x plus 5. Well, I'm going to take that 2x plus 5, and I'm going to put it in for the y in the other equation, okay? Then we're going to solve for the single variable. So whatever single variable we have, what's going to happen is when we substitute, two variables are going to go away. We're only going to have one left. Okay, so you're not going to have an x and a y. You're just going to have a y, or you're just going to have an x. Then, once you figure out what that single variable is, let's say x equals 2. Okay, what you're going to do is you're going to take that x equals 2 and you're going to put it back into the other equation and find out what y is. Okay, so we're going to have to do a lot of algebra here in these examples. Again, we leave our answer always as an ordered pair, x and y. So you're going to find a value for x and you're going to find a value for y. Okay, so let's take a look here at these two examples. Now, these two examples are not written down in your notes, so you're going to need to write these ones down as examples. Okay, I'm going to start off with the one here on the left, simply because it's a little bit of an easier one. I've got two equations. I've got the equation y equals 6, and I've got the equation y equals 4x plus 18. Now, you'll notice both of these equations are already solved for y, but you'll notice up here I already know that y has a value of 6. So what I'm going to do is I'm going to take this 6 right here, and I'm going to put it in for y. I'm going to substitute it in. So instead of a y, and you'll notice here on this equation, it's hard to solve this equation because it's got two variables in it. But if I know y is 6, I can put 6 in for y, and I have 6 equals 4x plus 18. Okay? Now I only have one variable. So by only having one variable, I can solve for x. What I'm going to do now, I'm going to subtract 18. I want to get x by itself here. Okay, so if I do that, if I subtract 18, 6 minus 18 is negative 12. And that's going to equal 4x because these guys go away. Then I'm going to do the opposite here. I'm going to divide by 4. And I'm going to get the value that x equals negative 3. Okay, now, so in my answer, I know right now x is negative 3. Okay, but what I would normally do is I would take this answer and I would plug it back into one of these equations. Well, I don't need to do that in this case because I already know that the y value right here is 6 units long. Okay, so then my x value is negative 3 and my y value is positive 6. This guy right here is my solution. That's where these two lines would intersect, at the ordered pair negative 3 and 6. Okay, so let's take a look at this next example. Now, you notice this next example is a little bit different because it doesn't have y equaling a number. Now it's y equaling an expression. So what I'm going to do is I'm going to take this top one. It says here y is 2x minus, or negative 2x plus 13. And I'm going to replace the y with a negative 2x plus 13. So I'm going to put that negative 2x plus 13 in place of the y. So it's going to be negative 2x plus 13 equals negative 3x plus 17. And now you'll notice that all I have is a variable of x. And I can work to get x by itself. What I'm going to do here, I'm going to add 3x. And then I get x plus 13 equals 17. Because again, these guys cancel out. Negative 2 and positive 3 is positive 1. I'm going to subtract 13 from each side. And I get x to equal 4. Okay, now, what I have to do is I have to take this x equals 4 and put it into the equation, right, into either equation. It doesn't really matter which one. I'm going to put it in the bottom one. So y equals negative 3, and instead of an x, I'm going to put a 4 in here, and then plus 17. Okay, so now I'm substituting again. Essentially, you're substituting twice in each problem. So y equals negative 12 plus 17. Negative 12 and 17 is a 5. So I have my two answers. My x value is 4, and my y value is 5. Okay, and this is my overall solution. That's where those two lines actually intersect. Okay, let's take a look at this third example here. Okay, the third example, again, a little bit different because now you notice that the bottom equation doesn't have a variable by itself. That's okay. We only need one equation to have a variable by itself. So you'll notice in this top equation, y here is by itself already. So because y is by itself, I'm going to take this and I'm going to put it in for y. So I'm going to put it in right there in that y. So what's going to happen here, this is going to be negative 4x minus 4, and then times, instead of y, it's going to be negative 5x minus 11. And it equals 12. So notice this time again, on this one, I substituted negative 5x minus 11 in for this y. Everything else stays the same. It's just there's no y here now. Okay? So now on this problem, I'm going to have to distribute. And these are the ones that get kind of tricky. And the reason I put this example in here is because of all the negatives that are here. So the negative 4x is going to carry down. We've got negative 4 times negative 5x. That's positive 20x. Negative 4 times negative 11 is positive 44. Okay. Now, I'm going to combine my like terms. Negative 4 and positive 20 is 16x. I'm going to subtract 44. And 16x is going to equal negative 44 and positive 12 is negative 32. Divide by 16. And x is going to equal negative 2. Okay. Now, again, I can put this into any equation I want to, but what I'm going to do is I'm always going to put it in the one where the variable is by itself. So I'm going to put it in that top one. Y equals negative 5 times, instead of x, I'm going to put a negative 2 in there because I know x is negative 2 now, and then minus 11. Well, negative 5 times negative 2 is positive 10, minus 11, and so now y is going to equal negative 1. Okay, so my ordered pair is the ordered pair negative 2 and negative 1. That is my solution. That's where those two lines will intersect. Okay, you should be able to complete all of your class kick problems now for 3-2, day 1.